Good morning, afternoon, or evening. Welcome back to Mr. Morrow's geometry class. I hope all of you are all doing well today. Today we're going to be talking about perpendicularity. It's a kind of funny word, perpendicularity. But it's basically, we're going to learn about perpendicular angles. And what is perpendicular? Well, perpendicular are lines, rays, or segments that intersect at or form right angles. Okay? Those are perpendicular. And if you notice, perpendicular is represented by that little symbol right there. It's in parentheses. But whenever I have this symbol, that means perpendicular. Okay? Parallel is something else. Parallel would be these two guys right here. That's parallel. And I always remember parallel because you spell parallel with two L's. And this looks like two long L's. Okay? But we're going to be dealing with today perpendicular. You got to learn these symbols. Just like the symbol of a line or a ray or a segment. These are very important symbols to know. Okay? Now, the examples below all show perpendicularity. If I tell you, okay, why is that not coming out? There it is. A is perpendicular to B. If it's perpendicular, and I tell you it's perpendicular, you can automatically put the little square here that represents that it's a right angle. Now the beauty of this, yes sir. Yes, if I were to tell you, what can you conclude if I tell you that line A and line B are perpendicular? Yeah, one of the conclusions is, well, I'd have to have a letter here, like let's say I had C, then you could say angle C is 90 degrees. And in this case, all of the angle C's are 90. Because if this is 90, and together that forms a straight angle, which is 180, that means that has to be 90. And then this has to be 90 because these two guys form a straight angle. And then, let me erase this. And then this guy has to be 90. Why? Because these two form a straight angle or these two form a straight angle. Thank you very much, son. Okay? I could have it in segment form. So this is in line form. Two lines that intersect, that create a 90-degree angle. They're perpendicular. DE, segment DE is perpendicular to segment EF. These are two segments that intersect at and form a 90-degree angle. Okay? Yes, sir, my brother. You cannot assume perpendicularity. You'd have to have either the symbol or the given. Yes, sir. Thank you very much. That's a great question, son. Then if I tell you here, this is JM is perpendicular to GH. Okay, in this case, I have a ray. GH is a little arrow there. You can see it on your notes. That's a ray, GH. And this segment, JM, that's 90. That means they have to be perpendicular. And then you can make an assumption here, not an assumption, you can conclude that K is also equal to 90 degrees. Okay? Because a straight angle is 180. If one of the angles is 90, or 180 minus 90 is 90. Does that make sense so far, gentlemen? Yes, sir, my brother. Are straight angles? Yes, sir. Yes. Okay, we can't assume that they're perpendicular because if I just go like this, okay, how do I know that that's not 60 and that's not 30? How do I know that that's not, or I'm sorry, 130 or 150? No, you cannot assume angles. Go back to chapter 1 and watch the video on what you can assume. You cannot assume right angles. You have to prove it, or it has to be given to you, sir. But that is an amazing question, and I thank you very much. Thank you. Okay. Now, in the figure below, okay, we've already talked about this, but we're going to reiterate it. The mark inside the angle, this little guy right here, indicates that angle B is a right angle. So therefore, it can indicate, it can conclude, it can prove, in this particular case, that segment AB is perpendicular to segment BC. And I can also conclude now and prove that angle ABC or angle B, you can read them both ways in this particular situation, is 90 degrees. Okay? But you have to be able to prove it. You cannot just look at two segments that intersect and say, oh, they're 90. Even if they look 90. In fact, we've had a few homework problems where we've seen it. That we've all been like, wow, that doesn't even look close to 140 degrees. But it's 140 degrees, and it looks like a 30-degree angle. Proof is in the pudding, especially in geometry. Now, it is important to remember that you can't assume perpendicularity. Okay? You cannot assume perpendicularity. For example, in triangle DEF, it sure does appear, guys, it appears that DE is perpendicular to EF. But we may not assume so. If I give you this triangle with no symbols, I don't tell you that DF is perpendicular to EF, you cannot assume anything about this triangle. The only thing you know is that this triangle is made up of segments DE, EF, and DF. That's all you can assume. But you cannot assume anything about the angles, and for sure, you cannot assume that it's 90. Sir? I cannot prove that they're all the same measure. So at this point, the only thing I know is that there's three sides. And I didn't say that they were or were not. All I can recognize, I said, is that DE is a segment, EF is a segment, and DF is a segment that makes up this triangle. Okay? Thank you, son. Great question. Now, remember from algebra, please, guys, that the x and y axis from the coordinate plane are perpendicular. That is for sure. It's just guaranteed. Please remember that when you're reading a graph, these are skills you have to know. This is your x value. This is your y value. X and y. But the x-axis and the y-axis, since the x-axis is horizontal and the y-axis is horizontal, this is 90 degrees. That you do not have to prove. You can assume that because that is a fact. The x-axis is horizontal and the y-axis is vertical. Now you may be saying, but wait a second. How is that different from two straight lines? Let me prove it to you. If I go ahead and do this, aren't those both straight lines? But can I assume that they're perpendicular? Do you guys see the difference there? Okay. Awesome. Yes, sir, my brother. Thank you. You're going to see now in a second. Okay? Thank you, sir. Good news. This is all the knowledge we have today. Now we're going to do some sample problems. Yes, sir. I'm sorry? Yes, absolutely. The SAT loves to do that all the time. The question was, will you ever give us a problem like this, but then at the end, once we do whatever proofs we have to do, they're actually perpendicular? Yes, I can do that to you. Absolutely. This has to get inside of your skulls, guys. You cannot assume angles in geometry. You have to prove them. So, wonderful question. Thank you so much. Thank you so much. May I continue? Because now we're going to do some examples. Yes? Okay. Thank you, gentlemen. Okay. Number one. Given angle AB is perpendicular to BC. Label, 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 label. That's a 90. DC is perpendicular to BC. Label, 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 label. I want to prove that angle B is congruent to angle C. So what do we always start with, guys? My givens, very good. And of segment AB is perpendicular to BC, and that is, of course, given. Now, let's not go to the next given yet. From this statement, from this given, what can I prove? What did I mark already? What can I prove? Thank you so much, and you hit the nail right on the head. Angle B is a right angle. Why? Definition of perpendicularity, which states, if two angles are perpendicular, then they form a right angle. We can use definition of perpendicularity. Definition of perpendicular sign. Yes, sir. You cannot condense it because then you'd have to, you would have had to have first put labeled both givens first. If you would have said AB is perpendicular to BC and DC is perpendicular to BC, then you could have said angle B and angle C are right angles. Definition of perpendicularity. How do you figure? AB is perpendicular to BC. That's one angle, sir. Did I just say that? If you combine both givens, then you could. I just finished saying that, but thank you, sir. Yes, sir. You could say that angle B is 90 degrees, but that would be an extra step, and that'd be kind of wasting your time at this point. Because the next step would be the next given. DC is perpendicular to BC, given. And then if DC is perpendicular to BC, what do I know for sure? That's exactly correct. Angle C is a right angle. Definition of perpendicularity. So you could go, further and say they're both 90, but why would you want to? Because now at this point, if I know angle B is a right angle, and I know angle C is a right angle, what do we know about angle B and C? Why? Right angles are congruent. Or you could say the right angle theorem. Does that make sense? Yes, sir. No. Because then they would have to be the same measure. So you have to say right angle theorem or right angles are congruent. Do you see now, my brother, why you wouldn't want to go to 90? You could, but it'd be an extra step. It'd be a waste of step. Yes. You could say in step 2 that angle B is 90, sure. And then instead of a right angle, sure. But actually, no. Because you'd have to define it was a right angle first, and then use the definition of right angles to prove that it was 90 degrees. So no. Thank you very much. Great question. Because remember, the definition of perpendicular, the two lines or segments or rays that form right angles. They don't say they form 90-degree angles. They say they form right angles. Now, we know that right angles equal 90 degrees. You have to go in that sequence. Okay? Now, what kills most of you? Algebra. KJ is perpendicular to KM. And I guess I should have put KJ and KM. KJ is perpendicular to KM. So if it's perpendicular, that means immediately that that's 90. Okay? And they say that JK is 4 times as large as MKO. JKO is 4 times as large as MKO. This would be angle O. I apologize. If I didn't give it to you, label, make a table. JKO, angle MKO. JKO is 4 times as large as MKO. What do I know nothing about? MKO, which I can call X. And JKO is 4 times MKO, so that's 4X. You had a question, my brother? This is K. Yeah, okay, hold on. J and K. Thank you. Okay? So now, JKO plus MKO equals 90. 5X equals 90 divided by 5. X equals 18. Find JKO. 18 times 4 equals 72 degrees. Simple algebra. You need to be an algebra master to do well in geometry, guys. I know it's tough, but I know you can do it. I believe in you. 100%. I believe in you. May I continue? Okay, thank you, sir. Number 3. Line EH is perpendicular to line HG. Name all the angles you can prove to be right angles. Yes, sir? Okay, angle H is kind of. Line EH, you would have a line. EH. Okay, well, that's ugly. And then you have line HG. Be careful. Okay, so what are the congruent angles here? What are the congruent angles? Not congruent. What are the right angles here, guys? Angle EHG, or you could call it angle GHE, or you could call it angle H. Okay? Well, in this case, it said name all the angles. So that's why we named them all. Thank you, sir. Yes, sir. Yes, I know, but name all the angles you can prove. They are the same angle, but this is all the ways that we can name them. So either of these would have worked. Thank you, sir. Thank you very much. Okay. Example 4. If I have that angle, that line A. Okay, sorry about that. Okay, so if A is perpendicular to B, okay, and C is not perpendicular to D, I want you to have the conclusion of that 1 is congruent to 2. Would that be possible? Would that be true? Would that be false? Okay, why? What would happen here? Why is this not even possible? Yes, sir. Very good. If A is perpendicular to B, that means this is 90. But if I tell you that C is not perpendicular, that means that none of these are 90. So how could angle 1 be congruent to angle 2? So this is not possible. Not possible. Okay? Yes, sir. Not if I tell you one is perpendicular and one is not perpendicular. How can they be possible? So if I tell you, an orange is the same as a banana. No, they're not. They're different fruit. Thank you so much, my brother. Yes, sir. Yeah, exactly. If C is not perpendicular to D, then none of these are right angles. None of them. Thank you so much. Great questions. Great questions. Now, last but not least, I've got here that EC is parallel to the x-axis. That little symbol right here, we already talked about, that's parallel. And RT is parallel to the y-axis. Okay, and actually, wait, did I do that right? No, RE. EC and RE. Sorry, my bad, guys. EC is parallel to the x-axis, and RE is parallel to the y-axis. I want you to find the area of this rectangle. Ooh, what do we do here? What do we do here? Yes, sir. Yeah. How do I find the length of RE? You can count the spaces or use the formula. Don't I go from -2 to 3? Right? So -2 minus 3, that's absolute value of -5, which is 5. So that's 5. How do I find from here to here? Right. From -4 to 7. So -4 minus 7 is the absolute value of -11, which is 11. So that's 11. And the area of a rectangle is base times height, which would be 55 units squared. The reason I put units is because I didn't say feet or centimeters or inches or yards or centimeters or meters. So it's just 55 units squared. That is perpendicularity, my brothers. Thank you as always. Great job. God bless you and have a great day. Hope you learned a lot.